Bismillahir Rahmanir Rahim. By the name of Almighty God, the most compassionate and the most merciful. I welcome all of you to your own channel. My name is Nasir Badi. Today we are talking about ionization enthalpy, lecture number 2. The aims or goals we have today is, first I will talk about the factors affecting ionization enthalpy or energy. There is a little difference between ionization enthalpy and ionization energy. We will talk inshallah for the next lecture about that one. And second, we will talk on variation of ionization enthalpy in periodic table. Two variation we will talk. First in period and number second in group. And the third part which we will talk is inshallah successive ionization enthalpy. Before starting the lesson, I will repeat, or maybe I will have a review that what is ionization enthalpy. Ionization enthalpy or ionization energy is amount of energy which we are giving to the atom in order to take out the electron from last shell. What do you mean? We have got lecture on ionization enthalpy in lecture number 1. We have nucleus, we have these shells. Now I want to remove this electron from the atom. Instead, you are giving energy to the atom, and by this energy electron is getting out. So this amount of energy which you are giving to the atom in order to take out its electron from the last shell, that's called ionization energy or ionization enthalpy. Now this ionization enthalpy depends on what? It means if we have hydrogen, in order to take out electron, if we have helium, in order to take its electron, or we giving the same energy to the hydrogen and also to helium, it means by giving, for example, 170 joule, if we give 170 joule to the hydrogen, also in order to take out one electron, also is it same that we give 170 joule to helium to take out its electron, or it's different, it's much more than this one or smaller than this one? Today inshallah we will talk about such subjects. Write it down. We will proceed inshallah. Okay, have you finished? Factors affecting ionization enthalpy. We have got many factors, but 4 or 5 factors, they are very important in ionization enthalpy. What do you mean? First, we have electron configuration. In electron configuration, if we have half fill or maybe full filled, on that occasion, stability of the atom is increasing. Since stability is increasing, ionization enthalpy or ionization energy is getting larger. What do you mean? For example, we have got p orbital. P orbital, it has got how many orientation? 3 orientation or direction. Orientation means direction. It means P has got 3 direction, px, py, or maybe pz. Now, if this one is half filled, it means if we have one electron, 3 electrons, or maybe d orbital, it has got how many orientation? 5. Now, when this one is half filled, if we put how many electrons? 5 electrons. And also, for example, this is p, this is p orbital, this is d orbital, or f orbital. F orbital has got 7 orientation, 1, 2, 3, 4, 5, 6, and this one is 7. If we have half fill, it means 7 electrons, or 5 electrons in D, or maybe 3 electrons in P. On that occasion, it's very difficult in order to remove 1 electron from its shell. It means we should give much more energy to the atom which has got half fill, or maybe full fill. In P, we have 6 electrons. This is full fill. Or maybe D, 1, 2, 3, 4, 5, 10 electrons. Or maybe an F, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is full fill, and this one is half fill. Now the atoms which has got like such electron configuration, on that occasion ionization energy is getting larger. Now ionization energy or ionization enthalpy is getting larger. Number two, ionization enthalpy is indirectly proportional to the numbers of electrons. Number of electrons, it means size of atom. What do you mean? Ionization enthalpy is indirectly proportional to number of electrons, or some people say ionization enthalpy is indirectly proportional to the size of the atom. Why? Because if we have, for example, this atom, this is nucleus, and this one is the shell, this is nucleus, and this one is the shell. Now, what do you think? If we have in here 1 electron, also in here we have 1 electron. In first case, electron is not in a large distance from the nucleus. It means for removing this electron, we should give much energy. Why? Because electron is more bounded to the nucleus. But in the second case, if we are removing this electron, it's easy. Why? Because it is not much bounded to the nucleus. In here, this proton, it means nucleus, and this electron, they are bounded to each other in a large amount of force. But in the second case, we don't have much force. We don't have much force when we are comparing to the first case. It means ionization enthalpy is indirectly proportional to the size. Size is increasing. The electrons are locating too much far. Now, the nucleus do not have this ability in order to pull it to itself. In order to bound the electrons for itself. For this result, ionization enthalpy is indirectly proportional to the size. Number three, ionization enthalpy is directly proportional to the number of protons. It means Z, or atomic number. Atomic number. What do you mean? For example, if we have this nucleus, it has got 2 protons, and also this is a shell which we want to remove its electron, and we have another, it has got more protons. Now this is the shell. What do you think? What do you think? We have large amount of force in the first case or in the second case? In the second. Now electron is more bounded to the nucleus. For this result, in order to remove this electron, we should give much energy compared to the first one. So ionization enthalpy is directly proportional to the Z. It means we have more protons. If we have more atomic numbers, now the attraction force is more. Since the attraction force is getting increased, ionization energy is getting increased. And also number 4, penetration of the orbitals. Penetration of orbitals. We have got S orbital, P orbital, D orbital, and F orbital. Now, what do you think? If we want to remove the electron from S is easy or P is easy? Answer is S is difficult, then P. P is difficult compared to the D, and P is difficult compared to the F. This is called penetration of the orbitals. Why? Because if we see this is nucleus and this is the orbitals, the orbits, and we have, for example, in here S, and we have P. S is more close than P to the nucleus. So the penetration is the another factor which affects on ionization enthalpy. It means ionization enthalpy depends on the penetration of the orbitals. From S is difficult compared to the P, P is difficult compared to the D, and D is difficult compared to the F. And the last one is screen shielding. Screen shielding. What do you mean by this one? For example, we have this proton, and also this is one shell, number 3, and also number 4. First, second, third, fourth, like this one. Now we have in here S orbital. We have here S orbital and P orbital. In here S orbital, we have P orbital, we have D orbital. For example, in here we have an orbital by the name of S. Now what do you think? This proton will attract the electron which is in S. But due to these orbitals, this proton will not be able to hold this electron which is far away. This is called screen shielding. Screen shielding, it means these orbitals have more effect, or they, what do you say? These orbitals indeed they screened the what? The nucleus. So the proton or the this nucleus is not able in order to hold this electron which is far away. Why? Because we have in here match orbitals which they affected like a screen shielding on the nucleus. It means we have 5 factors which they affect ionization enthalpy. First, electronic configuration. If we have half fill and full fill, the stability of the atom is increasing. Since stability is increasing, ionization energy or enthalpy is increasing. Number 2, ionization enthalpy depends on number of electrons. It means it is indirectly proportional to the number of electrons. Number of electrons, or in some books it's written size. Now ionization enthalpy is indirectly proportional to the size. Ionization number 3, ionization enthalpy is directly proportional to the Z or atomic number. If we have matched protons, the electrons they will attract much more. And number 4, penetration of the orbitals. It means it's difficult in order to remove an electron from the S than compared to the F, or D, or P. And number 5, screen shielding. If we have much more screen shielding, on that occasion, it's very easy to remove an electron from the last shell of an atom. Have you finished? I think you have got this one. Write it down. We will proceed, inshallah, our lesson. Have you finished? Okay. Now we will talk, inshallah, on variation of the ionization enthalpy in periodic table. Whenever you're talking about ionization enthalpy or variation on the periodic table, in periods, we will talk on in periodic table. We will talk, inshallah, just in 2 cases. First, period, and second, in group. Variation of ionization enthalpy in periodic table. Listen, whenever you're talking about variation of the ionization enthalpy in periodic table, we have 2 cases. First, in period. In period, it means from left to right. From left to right. Now, if you see from left to right, for example, period number 2. Period number 2. What are the elements which are in period number 2? I think lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Am I right? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Now, what do you think? What's the atomic number in lithium? 3. This is 4, 5, 6, 7, 8, 9, 10. It means whenever you are going from left to right, Z is increasing. Z or Z, whatever you are pronouncing. Z is increasing. Since Z is increasing, ionization enthalpy or ionization energy is directly proportional to the Z. It means ionization energy is increasing. If ionization energy is increasing, it means in here in period, neon has got more Zeit than fluorine. So neon is I think it has got more ionization energy than fluorine. So we have like this one. What do you mean? It means if we have neon and if we have fluorine, we have got electron here, we have got electron here. Now, which Zeit is more? Neon is more. If neon's Zeit is more, we should give much more energy to the neon in order to pick up or to remove its electron than compared to the fluorine. Fluorine will be much difficult in order to remove its subshell, its last shell electron than compared to the oxygen. And the easiest one is lithium. I think you have got this one. And also, this is the first group, first period. Whenever you're talking about second period, it's also the same. What are the elements that we have in second period? I think this is sodium, magnesium. We have got sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and xenon. Yeah, argon, I think, argon. We have sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and also argon. The atomic number of sodium, it's 11, 12, 13, 14, 15, 16, 17, 18. Now, from left to right, which factor is increasing? Atomic number. Since atomic number is increasing, ionization enthalpy is directly proportional to the Zeit. So ionization enthalpy must be increasing. Now argon is much more than chlorine, than sulfur, than phosphorus, than silicon, than aluminum, and then magnesium and sodium. I think you have got this one in period. Second, we will talk in groups. Whenever I'm talking in group, I mean from top to bottom. From top to bottom. What are the elements of the first group? It is lithium, then sodium, potassium, rubidium, cesium, and francium. Do we have this one or not? Lithium, sodium, potassium, rubidium, cesium. Now, what do you think? What do you think? Whenever you are coming down, lithium is in period number 2. The first one, we have hydrogen. Now, it means it's period number 1. It means hydrogen has got 1 shell. Lithium has got 2 shell. Sodium has got 3 shell. And potassium has got 4 shell. Now, what do you think? By coming down from the top to bottom, size is increasing. Size is increasing. This one, this one, this one, the radius is getting larger. It means size is increasing. Since size is increasing, ionization enthalpy, what's the relation of the ionization enthalpy with the size? It is directly proportional or indirectly? Indirectly. It means ionization energy or enthalpy is getting down or decreasing. If size is increasing, ionization energy is decreasing. So if ionization energy is decreasing, it means cesium is the lesser one, then rubidium, potassium, sodium, lithium, hydrogen. It means the order is cesium is lesser than rubidium, rubidium is lesser than potassium, and also sodium, and lithium, and hydrogen. This is the order of ionization energy in a group. And this is the order of the ionization energy in a period. But there is a question. That in first lecture, I plotted the graph in period and also in group. In period, we have, for example, in period number 1, we have like this one, the graph. What do you mean? From left to right, ionization enthalpy is getting larger. But why in here? This is why happened. It means ionization enthalpy or ionization energy does not relate just in two factors, maybe Z and also group, but we have 5 factors. Now in here we just mentioned just 2 factors. It means we order these elements according to 2 factors. First one is Z and number 2 is size. Up to now, we haven't mentioned another factors in periodic table. It means we have some exceptions, and those exceptions is coming out from the electronic configuration factors. Write it down. What I say, you will see inshallah. Okay. Now listen, you will get. Now listen to the exception. In period, what do you think? The order of the ionization enthalpy will be like this one or not? Yes, but we plot it just by taking the Z. We haven't mentioned any other factors. It means it's true that whenever you are going from left to right, Z is increasing, but ionization enthalpy, another factor which affects on that one is electronic configuration. What do you think? This is in which period? It's in second period. If this one is in second period, what's the electronic configuration for the last shell? This is 2s1, this is 2s2, this one is 2s2, 2p1, and also 2s2, 2p2, 2s2, 2p3, 2s2, 2p4, 2s2, 2p5, and the last one 2s2, 2p6. Now in here, if we have 2s2, it means this one is in full fill electronic configuration. In here, ps3, it means we have half fill. Now what do you think? This is ps4. In here, S is 2, but P has got just 1 electron. Now what do you think? Removing from a full fill is difficult, or from such atom? Full fill is difficult. It means we have a change in beryllium and boron. Also, here, nitrogen and oxygen. 2p3 is difficult, it's half fill. Or 2p4 is difficult. 2p3 is difficult. Why? Stability increased on half fill and full fill electronic configuration. It means we should change the place of nitrogen and oxygen with each other. Now, the correct order is lithium, then boron, then beryllium. And carbon, also in here, oxygen, then nitrogen, then fluorine, and then neon. Neon is much difficult. Why? Because it has got more Zi, and also it has got the best electronic configuration. S is also fulfilled, and P is also. It has got 6 electrons. Now this is the exception in period number 2. Also in period number 3, we have sodium, magnesium, aluminum, sodium, magnesium, aluminum, I think, silicon, phosphorus, sulfur, chlorine, and argon. We had this order, but it is in period number 3. What's this one electronic configuration? 3s1, the last one, the last shell, or the last orbit. This is 3s2, 3s2, 3p1, 3p1. This is 3p2, 3p3, 3p4, 3p5, and 3p6. And here we have full fill electronic configuration, and in here we have P, just 1 electron. So aluminum and magnesium ordered, they are replaced with each other. In here 3p3, we have got 3 electrons, but in here we have got 4 electrons. Now what do you think? We should change the place of phosphorus and sulfur with each other. So the correct order is sodium, then what? Aluminum, and then magnesium, then silicon, then sulfur, then phosphorus, then chlorine, and then argon. For this result, in the previous lecture, we had the graph such. Why this one? Although, for example, this one is lithium, this is beryllium, and this is boron. Although boron has more Zi, but why its ionization enthalpy is lesser? Because beryllium has got more stable than what? Boron. And here also we had, for example, nitrogen, and this one is oxygen. Oxygen has got more atomic number than nitrogen. But why decrease in ionization enthalpy? Because nitrogen is more stable than oxygen because of its electronic configuration. I think you have got this one. Now this was the variation which we had in period. In groups we don't have any variation. Just in one case, I think in group number 3 or 13, we can say. We have, that's due to the contraction of the f orbitals, but we will not talk on that part, because it would be more difficult in order to explain why. But if you want it, inshallah, we will take one example in examples lecture. It means for the next lecture. Okay, write it down. We will come, inshallah. Have you finished? Now we will come on successive ionization enthalpy. Successive ionization enthalpy. Successive ionization enthalpy. What do we mean by successive ionization enthalpy? It means if we want to remove step by step an electron from an atom, it is called successive. If we are giving the atom for each electron the energy, it is called successive energy of ionization. What do you mean? It means we have an atom like A. It has got a nucleus and also shell. For example, we have 5 electrons in here. Now, this atom is A. It is neutral. Why? Because its proton and electrons are same. Now, I want to remove one electron from this one. What do you think? If I remove this electron out, I should give some energy. This is ionization energy first. And the atom becomes A+. Why? Because it lost one electron. Second, this atom changed. This is nucleus. How much electron does it have before? 5. Now, how much remains? 4. So this is A or A+. It is A+. If this one is A+, I want to remove this electron out of this atom. For this one, we should give energy. So it becomes one electron is getting out, A+ changed to A2+. Am I right or not? Yes. So ionization energy is ionization energy 2. Also, this atom, which is A2+, it means it lost 2 electrons. Now remained how much we have? 3. And I want to remove this electron out. So we should give some energy. Now this A2+, which we want to take one electron out of that one, it changed to A3+. So ionization energy is ionization 3. Now the question is, ionization energy 1, 2 and 3, if we want to compare the amount of them, are they same or they are different? What do you think? First, ionization energy 1, ionization energy 2 and ionization energy 3, they are not same. Second, ionization energy 3 is more than ionization energy second, and ionization energy second is more than ionization energy first. What do you mean? It means why? Because if we have less electron, it means these protons, how much proton do we have in here? 5. How much proton in here do we have? 5. Because it's the same atom A. How much protons do we have in here? 5. Now what do you think? 5 electrons will attract 3 electrons much more or 4 electrons? Answer is 3 electrons. And also by removing out of each electrons, screen shielding will be lesser. It means if we have this atom and we have these shells and we have got in here orbitals, like this one, And if we have in here, if we want to remove each electrons from here, now the orbitals is getting lesser. If the orbitals is getting lesser, it means screen shielding is lessening. Now, if the screen shielding is getting lesser, so the electrons will be much bounded to the protons. By the way, we can say ionization enthalpy 3 is much more than ionization enthalpy 2 and then ionization enthalpy 1. I think you have got this one. Write it down. By the way, it was our second lectures. Inshallah, we will have one lecture more on ionization enthalpy, and we have the example sections. I will bring, inshallah, by the grace of Almighty God, the best examples of ionization enthalpy. Allah Hafiz.